Well, I really screwed up this time. Let me set this one up for you. I had to take my wife's car to the glass shop to get a chip in the windshield repaired. They did a great job, by the way. Since I was there, I figured I'd get them to cut a new piece of glass for the Jeep speedometer, since this had a piece of really scratched up plexiglass in it that didn't fit quite right. I figured the safest thing to do would be to reassemble the speedometer and put it back in the dashboard. I'd previously done some work cleaning this up, lubricating it, getting it freed up, and it seemed like other than the glass and missing needle, it seems like it works. Now that I've got the glass sorted out, the next thing to do was to very delicately remove the needle so that I could 3D print a new one. And I did manage to very delicately remove the needle, but I also managed to very delicately remove part of the shaft that it's on. Unfortunately, the rest of the shaft did not get removed. The end part of this shaft is about 30 thousandths of an inch. I think that's 0.7 millimeters. Absolutely tiny. This part of the shaft is a 16th of an inch, about twice that, which in millimeters is also about twice that. Now that the cursing phase is over and I've done some thinking and some tests, I've realized I'm in way over my head. So the only thing to do is double down on my mistakes and see if I keep digging this hole deeper, if eventually I'll come out the other side. This is dumb. Quarter-inch grade 8 bolt. The first step here is to turn it all down to a consistent diameter. Get rid of the threads, get rid of the heads. Now I can choke way up on it in the collet chuck. I need about 3/8 of an inch turned down to 30 thousandths. Trying to do that in one shot almost certainly wouldn't work, so I'm going to do it in 2 halves, because doing it in 3 halves seems excessive, but I'll take a lot of light cuts as I go. With it pulled out a little more, I can repeat the process to do the rest of it to length. Concentricity isn't extremely critical here, so using the collet chuck and keeping it in the same orientation as I pull it out should be more than good enough. Then it gets pulled out again for a step up to 37 thousandths for where it fits through the bushing on the housing. I left everything a thousandth or so large and fine-tuned it to final size with some very carefully applied emery paper. And then repeat the process, this time turning the remainder of the part down to a chunky 80 thousandths or so. Not a critical dimension. My idea here is to make a sleeve that will fit over the existing shaft, so I need to flip it around and drill a hole from the backside. So it's too small to actually hold on that diameter. So in order to drill this, I want it as concentric as possible, so we'll go basically as deep as we can. Pull it out a little. Actually, what I'm going to do is just set the drill bit, so once I get all the way in, need a little bit of meat there so it doesn't break through. Actually found a 54 thousandths drill bit, so I'm going to pilot drill with that. I can also choke up on it as much as possible. Chip clearing is a major issue with small drill bits like this, so it's a lot of pecking, and pilot drilling it'll also help to reduce the chip packing when I drill it to final size. So this shaft is pressed into the speed cup. Apparently this is called a speed cup. So I'm pretty sure that if I tried to get that out, I would just destroy the entire thing. So I made one that will sleeve over it. If I push it down the whole way, it should be just about right, which means I need to cut part of that off now. Marked out a little depth gauge on a drill bit on how deep that hole is. I was worried that this was going to be too loose of a fit. It's actually a slightly tighter fit than I thought it would be. I'm going to clamp that on the solid part. A little oil on this. Let's see if we can't get it to seat down in there. There's a little tiny sort of thrust bearing washer that goes on here. Where'd it go? There it is. The frame of the speedometer was staked together. In order to put it back together, I'm going to drill it and tap for a number 4 screw. It just blew out the side of that and walked. Remember to never put an end mill in a drill press unless you need to put an end mill in a drill press. I learned my lesson for the second one. That should work. I honestly can't believe how well this is working. We're not out of the woods yet. Next up, I need to get this spring off of this shaft and onto that shaft. It looks like there's a little split in that brass disc. I'm just going to kind of set it down in that little hole. Wonder if I can just push on it now that it's supported by that brass disc. Look at that. I need a little tiny punch. I ground down the tip of a nail. You know, when you're sharpening a nail, you know you're dealing with small stuff. Oh, I think I got it. Yes. So I pressed the long side out that way, so this is the back side of it. So it goes on like that. There's a little tiny slot in there. I don't even know if you can see it. I'm wondering if I can open that up just a little bit and make it easier to slide that on and then squish it back down. Well, it kind of went pop and slipped all the way back on there, so now I just need some tension on this spring. Of course, I have no idea how much tension to put on that spring. Okay. So that would be 0 miles per hour. So if we wind this spring around, hook it in there. I'll wind the spring up, and then when you let go, I guess now we talk theory on how this works. The speedometer cable is driven by the transmission, or in this case, transfer case. It comes up here as a little square drive that slots into the back of this and spins the outer part here. Inside there, there's actually a little bar magnet. That spinning bar magnet induces some eddy currents in this little aluminum disc in the speed cup and basically drags that over until that magnetic force balances with the force from this spring. Yep, the odometer is actually just driven directly from that cable with a series of 3 10-to-1 worm gears, which means 1,000 rotations on the speedometer cable is 1 mile. So if you're going a mile a minute, which is 60 miles an hour, the speedometer cable, the input, is spinning at 1,000 RPM. So if I take this nifty little 3D printed adapter piece and put it in my drill, set the drill on the slow speed, which is 600 RPM, we should see all of that move. And we got nothing, which means I have way too much spring force on there. I'm going to fiddle with this for a while. On further review, it seems like this needs a little bit of end float in it, and it was just binding up. Loosen these screws up, and I'm just going to stick some little pieces of shim stock in, and let's see if we can get it to be happier. So now, if I spin it with the drill, it does move. I have no idea if it's anywhere close to being calibrated right, but let's find out. And now we get to do the part that was the whole point of this to begin with. I 3D printed a needle, and I took the remains of the old needle off of this little counterweight and a hub. Black on black's not quite doing it for me. Of course, that's nothing a little white spray paint won't fix, and I'd say that looks pretty good now. For test and calibration purposes, I 3D printed a little piece that threads on here and is sort of a press fit for a little DC motor. And I've got a little window there, so I can use my little laser tachometer to measure the speed. I've got that hooked up to a variable voltage power supply. That might not be. And so, checking the calibration like that, it was really close, but I wanted to just tweak the hairspring a little bit. I broke the spring. I should have left well enough alone, but I guess failure is content, so let's see if we can fix that too. I tried just bending it, but that just means there's too much spring tension, and it's reading about half of what it should. And the more I try to tweak this, the more it breaks. So I dug around and I found a broken indicator, and it has a spring in it. I might be able to use that and just tune it to fit. I just need to make a little, I guess the watchmakers call that a collet. I found a suitable piece of brass or bronze or some sort of yellow metal. The first thing I'm going to need to do is drill a really small hole in there. It occurred to me that the only drill chuck I have that'll hold a small enough drill bit is this one, and I don't have an arbor for it, but fortunately at some point in the past when I was making some Morse Taper 2 arbors, I turned up a bunch of extra ones. That'll save me some time. It's funny because that drill chuck came from a guy that I picked a bunch of tools from, grabbed a bunch of other drill chucks from him, and he's, kind of threw that one in and said, "Here, take this one." I was like, I don't need one that small. Why would I ever need that? But here I am. Same thing with the drill bit. Last weekend I was at a flea market, and there was a guy with a whole bunch of different random boxes of drills, and well, I'm a sucker for a good random box of drills. I'm still just sort of getting into sorting through it all, but for $20, I think I did pretty well.
I should also address the inevitable question of why am I doing this instead of sending it out for repair or buying a new one or even buying another old one for parts. There's two answers to that. The first one is that stuff costs money. The second one is this really isn't in my wheelhouse and I want to see if I can do it.
Coming in with a slightly larger drill, just to kind of spot it. I'll go in with the real one, finger for scale there.
And yeah, I know my tailstock is off-center a bit, but I only have to go about 50 thousandths deep, and it doesn't really matter much if the hole wanders a little bit.
You know, I'm really not sure what I would ever need an 8,000 slitting saw for, why I would buy that, but I guess this is it. I don't even know if I want to place bets on this one. Well, since that worked, we're gonna go double or nothing on it. I'm gonna call it that this spring was on, and that indicator is done like this, where there's a little slot that I can squish down. Obviously put it on the middle, but I'll do that after I part this off. That might be the crux move. Not so much parting it off as parting it off without losing it. Got it. Yacht frickin' Z. This is another one of those things that I bought because I didn't know what it was, and it looked like it might be useful. It says Overman Wheel Company, Boston on it. Overman was an early manufacturer of bicycles. They were actually the first U.S. manufacturer of a safety bicycle, the form that we recognize as a modern bicycle. So this is probably some sort of bike tool. I'm not sure exactly what. If you know what this is, let me know, but right now it's working great for holding that thing for deburring it. Managed to get that spring crammed down into that little slot. I didn't video doing that because basically all you would have seen is the back of my hand. Well, let's see if that gets us anywhere even in the ballpark. Should probably hook up the wire. 920-ish RPMs, and we're at 50 miles an hour. Let's see if we can dial it into 60. It's pretty darn close. It's reading maybe 5 miles an hour off. So let's just try tweaking up like that maybe. Call that 30 miles an hour. Did I go the wrong way? Come on, give me a believable reading. Yeah, I think I went the wrong way. About 950. I'm at about 60 miles an hour. This is obviously not a particularly reliable test rig. It's hard to get good consistent results with this, but I think I've gotten this to the point where it'll give me some idea of how fast the Jeep is going. I should also be able to do this by time. If I'm going 30 miles an hour, it should take me 2 minutes to go a mile. Because remember, the odometer is based on the direct drive. Alright, that's a minute. So it went 0.65 miles in a minute. So it is reading a lot slower than it should. I stepped away from this for the evening and realized a few things. First, I should say that given that I almost have the skills, knowledge, and tools to fix this, I'm pretty impressed that this thing works at all. But stepping back from it, I realized there might be a few things that I can do to get this dialed in even better. The first issue I want to resolve is that this motor is rated for 6 volts and does 13,000 RPM, but I'm trying to run it at 1,000 RPM, so doing a direct coupler wasn't really working. Would be really nice if I had, the matching gear to do a gear reduction, so I can run the motor faster but still get that 1,000 RPM on the speedometer. For some reason it took me much longer than it should have to realize it, but I could just 3D print the gear. So now I can run the motor faster, get more torque, get a much more consistent speed, and I've got bigger target for my tachometer. So now I can actually get consistent readings with that. Unfortunately, the calibration is still off, especially at low speeds. I talked about how there are two opposing forces that make this thing work. The hairspring, which I have off right now, and the magnetic force. But there's also a third, which is gravity. And I don't have this needle balanced very well. So at lower speeds it has to work more to pick that needle up than it does at the top of the dial. And once you get past center, it's pulling back down. Let's see if we can't try to get that balanced a little better and see if that helps. For test purposes, I'm just going to kind of ball up some masking tape and try sticking it on there. "30 miles an hour, we're at 600. That's about 1100, just over 60, so that's pretty close. What if we make this heavier? Just move that mass out just ever so slightly. 433, so my ball of masking tape weighs 0.34 grams. Obviously it depends on how far out on the needle it is. Alright, we got needle version 2. A little bit more mass here. And some material cored out on that side of it. Before I go through the trouble of tearing this apart to see just how good the balance is, I might as well test it and see if we're close. That should be a little over 60, so we're high there. That should be about 22. That's actually close. I'm going to play with this for a little bit.
Look, I promised you amateur speedometer repair, so I don't feel bad using hot glue to help balance this thing.
50 miles an hour should be 833, and we're at 820 there. Should be 60, pretty darn close. Should be 30. Should be 166. We're at 188. I can't complain about that. I think that's as good as I'm going to get it. And I think it's actually pretty good. We'll find out once we actually get the Jeep on the road. But for now, I don't think I want to run the odometer up too much more. I mean, it was wrong anyway, because there was no speedometer cable on the Jeep. So I probably, just got it closer to the actual mileage by doing that. But let's put this back together. Do I know where the original screws for this went? No. We'll use these. I'm going to be back in here changing out some of these light bulbs and such, so we'll Loctite that later. I wouldn't mind getting that needle on there a little bit better. I also don't want to break anything. The old gasket for the glass is pretty well shot. So I 3D printed a new one out of some flexible TPU. And I printed a really thin one to go on the other side of the glass too. Give that a quick little cleaning on the inside. Not that it needed it. Pretty sure someone out there is going to be upset that I didn't paint any of this, but I'm kind of trying to save as much of the patina on this as I can. I feel like it kind of looks the part more than if I did a full restoration on this. Then this just all gets carefully squished together and bent over. There we go. Well, let's see about getting this thing installed. There are actually little studs on the back of the dashboard here that it just slots onto. This is comfortable. So while I'm under here hooking the speedometer cable up to the transfer case, it's probably a good time to do a shameless merch plug. If you're like me and you have so many projects you feel like you can never get any of them finished, you should probably check out my new Professional Project Collector Association t-shirt available at jeremymakesthings.net. It won't help you get any of your projects done, but at least let you know that you're not alone. Sometimes it's not about finishing your projects, it's just about collecting them. And they're easier to put on than this speedometer cable. I think I got it. Well, I think that was a hard-fought one to get one more part on this vehicle, but it's done now. Next thing to do is actually finish getting this thing ready to start moving under its own power again. I've been spending a lot of time working on that, and I was planning on that being the next video in this series, but I think this one was pretty interesting. I enjoyed it, and I definitely pushed myself to work at a smaller scale than I ever had before, and I hope you enjoyed it too. Thanks for watching.